Welcome, ladies, to the American Chemical Society. We have a special mission for you two. You have been chosen to meet Democritus. Are you familiar? Of course, he proposed the idea of the atom. Wait, dude, didn't he die in 370 BC? That's the twist. You two get to try out our newest technology, the Turnbulator SBI. Oh my gosh. Wait, whenever I see these time machines in movies, something always goes wrong. You're right. Are we gonna die? Are we gonna get stuck in a different time zone forever? Are we gonna... Again, we are still testing this new device, but we have performed some various successful missions. We'll do it. I think we're here. Let's check it out. Wait, don't be scared. We're from the future. I know that. Wait, how'd you know that? I'm just kidding. They did say you were a cheerful philosopher. Shouldn't we? Nah, she's okay. Anyways, we're here because the American Chemical Society chose us to communicate with you to show you how the understanding of the atom has progressed throughout history. Oh, the atom! According to my idea, the atom is an indivisible solid ball. So, Democritus, I have to ask, how did you come up with that idea? I broke something down until it cannot be broken anymore. Well, most of that is correct. Let's start with Lavoisier. Let's go back to the year 1785. 1785 to meet Lavoisier. Okay, cool. This guy, I'm solo, and now we gotta stop doing that. That's Lavoisier over there. He changed chemistry from qualitative to quantitative. Ooh, let's take a look. I did it! I have found the law of conservation of mass. What? Who was that? I was just curious. What is that? I have discovered the law of conservation of mass. It specifies that the mass cannot be created or destroyed. How did you figure that? I evaporated the water, so maybe you might think that the mass will be changed, but it won't, because mass cannot be destroyed. It was still the same mass. Let's go. Go! This was the year 1803, when Dalton discovered the atomic theory. Where is he? Do we have the right time zone? Oh, hello. I didn't know I had any visitors.
Stranger, there are 4 parts to the atomic theory. Now, the first part is that all matter is made out of atoms. The second part is that atoms of the same element have the same property and mass. And the third part is that compounds are formed by a combination of 2 or more kinds of atoms. And the fourth is a chemical reaction is the rearrangement of atoms. You are so lucky I wrote down all these rules on a sheet of paper.
Well, have you ever had tea before? No. I also wondered how water and air can occupy the same space. Yeah, sugar. But anyways, I did an experiment and... Oh, you mix it. Well, anyways, I did experiments on a mixture of gases. So then what... okay, thank you. So what... okay, so what I did was, it struck me. I found the relation between the atomic weight and chemical reactions. It was quite intriguing. Oh dear, you're going to have diabetes when you're older. Dalton helped us to understand atoms and how they are. Now, we can manipulate them to discover new things. Interesting. My name is Eugene Goldstein, and I think I discovered something that I like to call a proton. I did this by using a tube filled with a hydrogen gas. I used a discharged tube with a perforated cathode. I found positively charged particles shooting cathode using a gas discharge tube. Eugene Goldstein discovered the proton, which makes up many different things, and it changed how we experiment on things because we know that there is a different substance that we can manipulate into creating new things. Pretty cool. Hello, young champ. My name is Ernest Rutherford. I think I discovered the nucleus of an atom. Well, what I did was I took a piece of gold foil and I shot alpha particles at it. And I expected that the particles would go in a straight line right through it. But what happened was some of the particles were knocked back or knocked around, and that meant that there was something deflecting these particles, and that came to be a nucleus. And this experiment is what I call the gold foil experiment. We use Rutherford's model to explain how much energy is in an atom. It gives us a mental picture of an atom. It helps us discover new things. My name is Thompson, and I discovered the electron. An atom, and also, because of this, I discovered that the atom can be broken down. I did this in 3 different experiments. I figured this out. In all of them, I used the cathode ray. In my first experiment, I built a cathode ray tube with a metal cylinder on the end. The cylinder had 2 slits in it, leading to electrometers. I found that applying a magnetic field across the tube, there was no activity recorded by the electrometers, and so the charges had been bent away by the magnet. This proved that the negative charge and the ray were inseparable and intertwined. In my second experiment problem, I constructed a slightly different cathode ray tube with a fluorescent coating at one end and a near-perfect vacuum. Halfway down the tube were 2 electronic plates. As I expected, the rays were deflected by the electronic charge, proving beyond doubt that the rays were made up of charged particles carrying a negative charge. In my third experiment, I decided to work out the nature of these particles. They were too small to have their mass or charge calculated directly, but I attempted to deduct this from how... Then I found out that the charge and mass ratio was so large that the particles either carried a 1,000 times smaller than a hydrogen ion. I came up with the idea that cathode rays were made of particles that emanated from the atoms themselves. In the plum pudding model, each atom had a sphere filled with a positively charged fluid. The fluid was called pudding. Scattered in this fluid were electrons known as plums. This is J.J. Thomson. The reason why he's significant is because he approved that the atom was indivisible, and that it's also the most fundamental unit of matter. Okay, hello, young champ. My name is Niels Bohr, and I discovered the electron levels. What I did was I used cathode ray, and I proved that that Ernest Rutherford's model wasn't completely accurate. So the electrons existed on different levels of energy at different distances from the nucleus. If an electron gained energy, the electron would leap to another level. And I discovered that the center, well, actually I didn't, Rutherford did, that the center is the nucleus and it's surrounded with electron shells, which is electron levels. Neil Henrik David Bohr gave us an accurate mental picture of an atom, so we can experiment with it and discover new things. Hello, my name is Erwin Schrödinger. I think I am very close to discovering the quantum mechanical model for the atom, which is the movement of an electron in an atom as a wave. I began with the classical equation for the properties of waves. This was this year, 1926, and this equation tells us the characteristic of electrons have fixed energy quantities. The position of an electron is described by me as a probability distribution map called an orbital. Schrödinger is also very important because he made the advancement in both quantum theory and color theory, contributed to the wave theory of matter, a form of quantum physics, and he devised the mathematical equation of wave mechanics. Hello, my name is James Chadwick, and I have a hunch. I have a hunch that there is something more in that atom other than electrons, more in that atom that there are protons. I believe that there's such a thing as a neutron. Jimmy Neutron? James. It's James Chadwick. In my experiments, alpha particles are projected towards a beryllium target. The emitted particles fall on paraffin wax, which in turn releases another type of particles. The study of the properties of such particles showed that they are protons. From the energy calculations, I showed that the particles released from beryllium as a result of the incidence of alpha particles on it are uncharged and have the same mass as protons. I like to call them neutrons. The reason why Chadwick is very important is because this new idea dramatically changed the picture of the atom and accelerated discoveries in atomic physics. And physicists soon found that the neutron made an ideal bullet for bombarding other nuclei. Go! Yeah! I guess that we're gonna have to go home tomorrow because... Thank you guys. You guys really helped me. No problem. Bye! Bye. No? No! Yeah! No. Should we do this? Nah. Okay, Home Alone. No! You're so mean! Whoa. You are a strange young lad. Oh, yeah, I'm English. Right? I don't know. Go check. You know what? Way too long and boring. They were really great. They are James Chadwick loves Hubba Bubba. Hello, mate. No, that's Australian. How do you want me to fall? Die.